Hello, I'm Pratha Kamran, and today me and my group members will present the different energy scenarios for off-grid communities of Ramea, Iqaluit, and Brochet in Canada. First, I'll introduce all these three areas. So Ramea was inhabited by settlers in early 19th century, and it consists of the 5 islands. It is a fishing town. After the fishing industry collapsed, it became a pioneer in seaweed industry. It had a population of 388 last year and is accessed by ferry only. Then Iqaluit is the capital city of Nunavut with approximate population of 8,200 people. It is the largest off-grid community in northern Canada, which entirely relies on diesel. QEC is liable for generation, transmission, and distribution of electricity. Then Brochet is located in northern Manitoba on the northern shore of Reindeer Lake, which is the Saskatchewan border. It is designated as the Northern Community of Canada, and the total population of Brochet is 537, with 126 residential units and 19 non-residential facilities. So all these areas have off-grid community and have off-grid energy systems, and they depend upon diesel as their main energy resource. These locations are remote, and transmitting power from grid is really expensive because of the cost of transmission line and extreme weather conditions. Different off-grid renewable energy systems are suggested and are invested upon as they are the main solution. Our report will highlight different energy scenarios and the energy utilization, greenhouse gas emissions, and environmental impact, and also the future clean energy projects in these areas. First of all, I'll introduce Ramea, which is located in Newfoundland and Labrador. So if you look at the energy sources, diesel is the main contributor and a fraction of power is produced by wind energy. Diesel contributes to 90%, while wind production is only 10% of the produced energy. Ramea produced about 4,200 megawatt in 2005, and it has a peak load of about 1,000 kilowatts during winters. So if you look at the power systems, diesel plant capacity is about 2.775 megawatt. In 2004, they installed 65 kilowatt wind turbines, which added a total capacity of 390 kilowatt. And in 2007, they installed 300 kilowatt wind turbines, and then hydrogen storage was also added. If we look at the figure on the right, it shows the power system in Ramea, which has the 3 big diesel generators and then 6 small wind turbines and also 300 kilowatt wind turbines in a hydrogen system. If you look at the energy utilization, residents of Ramea use wood and furnace oil for heating their homes in winter. There are 335 customers that use the diesel plus wind generated electricity, and approximately 30 to 40 cars come and leave this island every day. Most of the electricity consumption is by houses, while some percentage goes to small businesses and industries. The exact percentage could not be found because a proper survey has not been done yet. If you look at the greenhouse gas emissions and environmental impacts in Ramea, so before the wind farm installation was done, there was 100% diesel-based energy with a fuel consumption of 1 million liters per year and an average of 3,300 tons of greenhouse gas emissions. But when the wind plus diesel hybrid power system was introduced, it displaced about 425,000 kilowatt hour of diesel energy, and it saved about 120,000 liters of diesel. The GHG reduction was as follows: 320 tons per year of carbon dioxide, 6.8 tons per year of nitrogen oxide, and 0.43 tons per year of sulfur dioxide was seen and reduced as overall GHG reduction. It is also shown in the figure below. So right now, 2 clean energy projects are being done and monitored in Ramea. So first was the hydrogen energy storage system integration. This was introduced in 2010, but is still being monitored because of the issues that arose with it. Especially in 2018, it was shut down because of some severe issues in this hydrogen system. So this was mainly done because hydrogen energy storage makes use of wind farms, and energy that was wasted previously could be used now, and around 50% of wind energy that was produced could be stored in hydrogen tanks. If this project runs successfully, 1 billion kilowatt hour of diesel energy production could be displaced, and a diesel fuel saving of 270,000 liters could be seen. A GHG reduction of 750 tons per year of carbon dioxide, 16 tons per year of nitrogen oxide, and 1 ton per year of sulfur dioxide could be seen. The second project is in planning phase right now. It is the pumped hydro storage system integration. Different feasibility analysis have been done. So sizing indicates that adding a 150 kilowatt pumped hydro storage system will increase the renewable energy fraction to 37%. This is a overall higher efficiency than hydrogen storage and could easily be maintained by local technical expertise. So the study shows that building a 4,000 meter cube of water reservoir on the Man of War Hill for excess wind energy storage could achieve a head of 63 meters and could be operated by seawater. And because the transmission line is already available, this is probably the best solution right now for Ramea, but it is still in planning phase.
Hi, my name is Nafis Ali and I'm gonna present the Iqaluit and off-grid community of Nunavut. So first of all, I will shed light on the energy scenario of Iqaluit. So there is no commercial crude oil production in Nunavut. Diesel is the only source to produce electricity which is being imported by the government. Iqaluit power plant produced around 60,000 megawatt in 2017 with an average peak load of 9,700 kilowatts, and it has the installed capacity of 25,430 kilowatts. And Nunavut has some of Canada's highest electricity rates. Nearly 80% of all energy costs in Nunavut are covered by the government of Nunavut to keep the cost of electricity reasonable. So when it comes to energy consumption, so 79% of the total energy is being used by the station energy sectors, which are industries, residential and commercial building, and the rest of the energy is being used by the transportation sector and waste. So there's a picture which illustrates the designs of homes in Iqaluit. As you can see in the picture B, it shows how wastewater is removed from the homes. Picture C shows the indoor water tank, and D shows the transmission lines, and E illustrates the storage tanks for heating oil. When it comes to GHG emissions, industrial sector has the highest GHG emissions, followed by the residential and commercial buildings and agricultural sectors. And Nunavut's energy production had a greenhouse gas intensity of 800 gram of CO2 emissions per kilowatt hour. And as you know, the whole city is electrified by the diesel powered generators, which are the major source of GHG emissions. Diesel kept in the storage tanks throughout the year, which often contaminates the water through spillage. It also emits toxic pollutants like particulate matter, volatile organic compounds, and nitrous oxide, which worsen respiratory problems and can contribute to smog. So here, so these are the projects to reduce consumption of diesel. The QC intends to switch a portion of its electricity generation to renewable energy in order to reduce its dependency on diesel, and they are encouraging locals to become energy independent by offering some subsidies. The Clean Energy Corporation have recently revised their policy to let independent power producers to create and sell electricity. And these are the potential renewable energy resources available in Iqaluit, and due to insufficient fundings, they did nothing to harness these resources yet. And the most important one is the tidal energy, because this is possibly the finest renewable energy substitute for diesel in this region. Iqaluit has some of the highest tides in Canada, and it has the potential of producing 30,000 megawatt from 34 different locations. Epcak Renewable Energy Company proposed to install underwater turbines, but the government of Nunavut did not allow them to do so due to risk and environmental reasons. And these are some other options which can be considered while cut down the diesel consumption. Energy efficiency retrofits and district heating system. It can work by collecting the residual heat from industries and then delivering it to the households. And solar energy generation with net metering. Customers are permitted by QC to generate up to 10 megawatt from renewable energy resources and send any excess electricity to the local grid in exchange for credits applied to the monthly bills. And there's another one, you can also capture the carbon by utilizing the CCS technology. So here is an end to my presentation. Thank you.
is a off-grid community located in northern Manitoba and also considered the northern community of Canada. First of all, I'd like to discuss the energy scenario. The Brochet power station consists of three diesel generator and it has a capacity to generate 2.63 megawatt. People of Brochet also uses oil furnaces for heating purpose. Some of the homes still use wood for heating and cooking. Using oil to heat a home directly with a liquid fuel furnace is approximately 1.9 to 2.8 times more efficient than using a diesel to generate electricity, which is then used to heat home with resistive heaters. As we know that the Manitoba generate most electricity through hydro, that is almost 27% is shown in the figure. So majority of the diesel used by Manitoba Hydro comes from Alberta, which is transported to Enbridge Mainline or from Saskatchewan through rail. And here's the diagram that shows the Enbridge Mainline, and that started from Edmonton and passes through the main cities of Saskatchewan and Manitoba. The emissions of Manitoba is very much less as compared to the whole all provinces, and the data depicts that the each kilowatt hour of electricity generated by the province results in 4 grams of carbon dioxide emitted, while in Brochet, each kilowatt hour of diesel generated electricity result in 740 grams of carbon dioxide. GHGs are emitted from extracting, refining, transporting, and burning diesel fuel. Now the environmental effect, first of all the terrestrial effect, diesel spill potential is always there with this storage facilities and associated piping, and it can result in surface and groundwater water contamination. Each and every house and commercial building has oil tank and which is connected to a oil furnace. These tank lines and furnaces are all prone to leaking. The diagram shows the potential point where the leakage can occur. The other one is the aquatic effect, which is greater risk to aquatic life. As we can see in the picture, there is a diesel truck all over in the winter due to best ice condition, which is very dangerous for fishes, which is a source of food for the people in Brochet. It also damages the air quality as the studies conducted by Manitoba Hydro on 2006 load forecast shows that the CO2 emissions will reach to 0.11 megaton in till 2041. There are also several wood stoves being used in the community that are not efficient compared to the US Environmental Protection Agency certified efficiency stoves. These uncertified stoves used in Brochet are likely emitting 3 to 4 times of fine particulate as we can show in the figure, and they can cause chronic and acute respiratory diseases. There are many clean energy projects in Brochet which are discussed between the Manitoba Hydros, the provincial government of Manitoba, and the federal government. First one was the smaller scale hydro, as the Manitoba generates his whole almost all of the electricity by hydro, so it was considered, but the high cost and the high construction time time was the main obstacle. The other thing that the flow condition near Brochet is not so good, which cannot meet the capacity of the community. Second was on natural gas, but due to the logistic reason challenges and high cost due to the high cost of connection to central gas existing network, it was also ignored. Third was augmented diesel generation with power, which is in development phase and are discussing, and the Manitoba Hydro is discussing with provincial government to install the system. This option will decrease emission, but it will not eliminate the use of diesel generation because wind generation cannot meet the demand of the community and it can be used in a combination with diesel generators. Fourth one was the solar, which can be used on individual basis to reduce residential electricity demand. And the other was with connecting with Saskatchewan grid, which is located at the Molston Lake, and another was the connecting with Manitoba grid. As we can see that the Manitoba grid connecting with the Manitoba grid is difficult because the large distance.
In conclusion, every off-grid area that we discussed is dependent on diesel-powered electricity, but with renewable energy projects currently planned or under construction will help decrease diesel's dependence. It will also provide benchmarks for off-grid systems and reduce GHG emissions and environmental impacts. Thank you.